Hi, thanks for dropping by. I am teacher Donna Infante and welcome to Panic Learning. This is my first upload and I am excited to share with you something about motion. Motion is everywhere. We can see it in the movement of vehicles in the road, in the plant's sway, in the everyday activities of people, and even the smallest particles called atoms. They vibrate. That is according to Lesson 1 of Going Places Module 9. Motion is very easy to recognize, but has been very hard to describe. There are several physical quantities that can describe the motion of objects. Some of them are distance and displacement. Distance is the length between an identified reference point and a designated position. It is a scalar quantity, which means that it is described by a magnitude or numerical value only in units such as meter, centimeter, kilometer, mile, and feet. Here is an example. The distance between the light post and the girl named Bernadette is 20 meters. This means that the length between the reference point, the light post, and identified position of Bernadette is 20 meters. While displacement, on the other hand, is defined as the change in position of an object. It is a vector quantity, which means it is described by both magnitude and direction. It can be described as the difference between two distances, thus leading to formula d is equal to d1 minus d2 for opposite direction and d is equal to d1 plus d2 for straight direction. For example, Esau travels 150 miles to south but then traveled 75 miles back to north to pick up a friend, Sheila. Since Esau traveled south and back to north, she traveled in two opposite directions. So we will use the formula d is equal to d1 minus d2. These are our given. Then we substitute 150 miles minus 75 miles is 75 miles. Another example. Carl moved 15 meters north and moved 5 meters east. What is Carl's total displacement? Carl traveled in an adjacent direction, so we will use the formula. D is equal to D1 plus D2 this time. The given are 15 meters for D1 and 5 meters for D2. We substitute 15 meters plus 5 meters is 20 meters. Another way to describe motion is by speed, velocity, and acceleration. They differ from each other. Speed measures how fast something moves in terms of distance traveled over a certain period of time. To calculate, we divide distance traveled by the amount of time taken. So that's S is equal to D divided by 2. Wherein, again, S is speed, D is distance covered, T is time traveled. Speed is expressed by the units m, meter per second, kilometer per hour, miles per hour, and meter per minute. Share ko lang. Our tongue is the fastest healing part of our body. It is because our skin tissue has several layers of ectodermal tissue to reconstruct when it is wounded. Since mucous tissue has a much simpler composition and has a faster, more straightforward regeneration process and shorter time period. That is according to Josie Lane Dentistry. Going back, to easily remember the formula when computing for speed, distance, and time, remember this triangle. So here are the formulae. D is equal to S multiplied by T. Speed, we divide distance by time. For time, we divide distance by speed. For example, LeBron runs along a 250-meter distance in 45 seconds. What is LeBron's speed? Since we are looking for speed, we will use the formula S is equal to D divided by T. Here are the given. We substitute, that's 250 meters divided by 45 seconds. The answer is 5.56 meter per second. Another example. Leiden traveled 8.50 kilometers per hour in 1.5 hours. How far is the distance Leiden traveled? In this problem, we will use the distance formula. D is equal to speed divided by time. Given, then we substitute 8.50 kilometer per hour by 1.5 hours. So that's 12.75 kilometers. Last example. Elmo runs at 6 km per hour in a 15-kilometer distance race. How much time will Elmo need to finish the race? We will use the formula. T is equal to D divided by S. Given, then we substitute, that's 15 kilometers divided by 6 km per hour. 2.5 km per hour is the answer. Let us move on to velocity. It is a vector quantity that indicates displacement, time, and direction. Unlike speed, velocity measures displacement, and again, displacement is the measures between two distances. To calculate velocity, the formula to be used is V is equal to D divided by T, wherein V stands for velocity, D is displacement, and T is time traveled, or time interval. For example, JC walks 8 kilometers south in 3 hours and 5 kilometers east in 2 hours in an adjacent direction. So, we will add the two distances as our displacement first. Here are the given for two distances and two time interval. Solution: 8 kilometer plus 5 kilometers, that's 13 kilometers. 3 hours plus 2 hours is 5 hours. So there's 13 kilometer divided by 5 hours is 2.6 kilometer per hour. Another example. Mavi walks 11 kilometer east in 3 hours. And then 5.5 kilometer west in 2 hours. This time, Mavi walks in two opposite directions, so we will use the formula wherein we subtract the two distances as our displacement to get the velocity. And lastly, given, we substitute this 5.5 kilometers divided by 5 hours is 1.1 kilometer per hour. Lastly, acceleration measures how fast the velocity changes with respect to time. This means that a body or an object accelerates whenever there is a change in speed, change in direction, or change in both speed and direction. To solve for acceleration, we use the formula A is equal to Vf minus Vi divided by time. Vf stands for final velocity and Vi stands for initial velocity. Acceleration is expressed in units such as meter per second squared, kilometer per hour squared, mile per hour squared, and meter per minute squared. For example, what acceleration is needed to accelerate Raven's car from 25 km per hour to 58 km per hour in 3 hours? In this problem, we are to speed up Raven's car from our initial velocity, which is 25 km per hour, to our final velocity, which is 58 km per hour. This is the formula, and substitute the given. 58 km per hour minus 25 km per hour is 33 km per hour, and divide it by 3 hours, that's 11 km per hour squared. Here you go. I hope that you get to understand the difference between distance and displacement, speed, velocity, and acceleration. Tune in for our next video in Panic Learning. Thank you and keep safe.